Right, we're starting this topic paper, periodic table. And we'll add to as we go along. Right. Complete the table to show the relative mass and relative charge on a proton, neutron, electron. So a proton has a mass of 1, a neutron has a mass of 1, and this is a very, very small mass. Right, sometimes you'll see the figure 1/2000. What that means is you need 2000 electrons on a weighing scale. So if you had a weighing scale like this on one side and you had one proton on this side, they would balance out. So right, the relative charge, protons are pluses, electrons are negative, and neutrons have no charge. Nope, that's a bad example. Let's put no charge here. We can just put 0. Right. Look at this word isotope. Remember, we know hydrogen as 1, 1. What that means, you have, this is called the atomic number. If you look on the periodic table, you'll see that. And this here is called the relative atomic mass, RAM. This bottom number stands for the number of protons. Proton. Isn't that a Malaysian make of car? Anyway, this tells you the number of protons and neutrons. Oh. Neutrons. Okay, now here, if you look here, we have one proton. One proton, that is what makes it a hydrogen atom. However, here we have 3, a mass of 3. One of them's a proton. These two are neutrons, N and N. That's why it's got a mass of 3. What you do, you take the top number away, sorry, you take the bottom number away from the top. So I'm going to do 3, take away 1, it's 2. That tells me the number of neutrons. Okay, there you go. State number of protons, neutrons, electrons. Right, so the number of protons we said was the bottom number. So that is 1. Number of neutrons is 3 take away 1, which is 2. And the number of electrons, so right, the number of electrons equals the number of protons. So number of electrons, they're both equal because each atom is, what is it? Neutral. There's no overall charge. So let me do that. 1, 2, and 1. What's the term isotope? So you've got to learn this. I'll write it here. An isotope isotopes are Just learn it like this. Atoms of the same element right, and just learn it like this, that have the same number of protons but different number of neutrons. Right, just leave it like this. Don't start trying to do anything fancy than that. Just leave it like that. Right, okay. Right, what I would do with this question, right, they want the relative atomic mass. They want the relative atomic mass or the average relative atomic mass. So what you do, bromine 79 tells you, so that's bromine, the number 79 at the top and the number 81 at the top. Yeah, the relative atomic mass is 79, the relative atomic mass for this is 81. What you do is just simply get into this habit. No, let's try that again. Yeah, now draw a fraction line. Put 79 times the percentage plus 81 times 49.3, which is a percentage, divided by 100. And that's it, because look, them two will add up to 100%, and that goes at the bottom. And you should get 77.99. That's it, done. It's a maths question more than anything else, that. Right, just remember, periodic tables going down in a column are called groups, are in columns. And when you go across 1, 2, 3, 4, and so on, these are called periods. Okay, the period tells you how many shells, electron shells you have, how many electron shells you have. The group number tells you how many electrons on the outer or the on the outer shell or the valence shell. Just leave it like this. If you can learn them two, it'll help you a lot. Right, right, in each part of this question put a cross here. Okay, a metal. Right, what you do is start here. See if we can do that. Yes, well, look. You go down here, you go across. Just make it smaller, and just make it smaller. Right. Start here, go across, down, across. Just step all the way down. One step, and then them two. These here are the non-metals. Okay. And these here are the metals. That's poor, that is. Let's try that again with something else. Right. These are really. These are metals. That will go over there. That'll be a non-metal. Hydrogen and helium. Right, metal reacts violently with water. So it's gonna be one of these two. And I know group 1 metals, as they go down, they become more reactive, so it'll be B. A noble gas. Right, what you've got to know. How should I do with this? Let me rub all this out. Let me rub all this out so it doesn't cause any confusion. Right, now. Group 1, you've got to know, are called Group 2 are called alkaline earth metals. You have to know this. You just got to keep going. Group 7 are called halogens. Group are called noble gases. There you go. A noble gas will be A. Group 2 metal, so that's group 1 and that's group 2. So it's E, and a halogen is down here, which is C. Okay, there you go. Complete these sentences by placing, right, elements that are arranged, right. You've got to know this as well. Elements in the periodic table are arranged. Very important you know this. In increasing atomic number. Right? Elements in the same group in the period have the same number of electrons in the outer shell. We discussed that. Right. Learn these two off by heart. So this is going to be simply a fact recall. This is useful as well. Group 1, Group 2, Group 7 and Group, I call it Group 8, but Group 0. Right, and let's keep going. Right, so this bit here in the middle that I've circled is called the nucleus, and it has a overall positive charge. That there is an electron. This is an electron shell. This is the outer electron shell. There's one here as well. Here, this one. Right. Also remember the maximum number of electrons you can have on the inside is 2. Then on the next shell you can have 8, and then 8, and then really you're not worried about that, because you just need to know the first 20 elements. So if you look carefully here, you've got 1 proton, 2 protons. Can you see the pluses? I'm just covering them. 2, 3, 4, 5 and 6. So we have 6. The positive ones are called protons, and we had 6. So we're going to have the same number of electrons, 6. And now you've got neutrons. They don't have to be the same, but in this case they are. If you look, 1, 2, 3, 4, 5, 6. Ooh, no, 7. I lied. 7. Okay, protons, electrons, and yeah, there you go. Right, give the mass number. The mass number, right, because the electrons, remember electrons are so small in size, is it 118? I remember it as 1 over 2000, but they said it was 1840. Okay. Because it's 1 over 1840, we ignore the electrons. Alright. So we just need to count the number of protons and electrons. So if I were to do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we know it's 13. But because I'd counted the number of protons and neutrons, if I added those, I would have got 13. Right, here's a definition of an isotope. Isotopes are atoms of that have the same number of protons but have a different number of neutrons. There you go. Let's keep moving on. Right. Can you see the word isotope? This is carbon 12. That means it's got a mass of 12, 13, and 14. What that means is, right, 6 number of protons. That's what makes it a carbon atom. And then if you did 12, take away 6, you get number of neutrons. That's 6. So if I did 13, take away 6, I would end up with 7. And if I did 14, take away 6, I would end up with 8. So remember what we said. So the number of neutrons, so let's do this. Carbon 12. So that's number of protons. Where are we? There. That's the number of protons. And this is the number of protons and neutrons. So all I do is I do 12, take away 6. There. That's where that 6 comes from. Now I'm going to look at this one. Carbon 14. 14 take away 6. 8. So it's got 8 neutrons. Right. Explain in terms of electrons why the 3 isotopes have the same chemical properties. Right. Because they have the same number of electrons on the outer shell. Right, outer shell. Yep, okay. Right, remember what we said about, instead of using the word outer shell, we could have used the word valence shell. Right, what is meant by relative atomic mass? And it's given the symbol AR, relative atomic mass. Right. So this is the average, because remember when they use the word relative, it's relative to carbon 12. This is the average mass of an atom. It's the average mass of an atom compared to, no, what can you say? How can you say? 1/12, I don't know how to, 1/12 of a carbon 12 atom. Right, let me try to explain that. 1/12 2, 3, 4, 5, 6. Proton, 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 proton. 7, 8, 9, 10, 11, 12. Neutron, 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 neutron. So a carbon 12 looks like this. It's got 6 protons, 6 neutrons. We ignore the electrons in terms of the mass. So what they said was a carbon atom weighs 12 units or whatever it is. If they split it up into 12 parts, one of those parts is going to be 1 unit. So now if you've got this, for example, is it sodium 7 3? So let me just quickly check that. 7 3. Yeah, it's 7 3. What this is saying, this has got a relative mass of 7, so that means it's got 3 protons, 1, 2, 3, and 1, 2, 3, 4 neutrons. So this has a relative atomic mass of 7. So you'd say AR of 7. We'll just leave it like that. So can you remember this is a similar question to the one we had earlier? How do we work this out? Draw a big fraction line. It's carbon 12, so we'll do 12 times the percentage plus carbon 13, 13 times the percentage, all over 100. And your answer for that should be, according to the mark scheme, 12.1 units, or that's the relative atomic mass. That is it. Right. Hey, these become alkanes. What's going on? I don't know whether I should do that, you know. Right, what I'm going to do, I'm going to ignore those because I think they're going to come up in alkanes and alkenes. Is that a good thing? Yeah. Yep. Okay, we'll ignore that. We'll ignore that. Right, we'll go to this question. Right. Which particles have the same mass? Which particles have the same mass? Oh, okay. I was looking at the table. Right. Neutrons and protons. Remember we said electrons are a fraction. They're not a half. They're 1/1840. And I tend to remember 1 over 2000. So they're very, very, very small. What is the atomic number of P? So P is there. The atomic number is, oh, that's terrible. It's this one. The atomic number, not relative atomic mass. So it's got an atomic number of 6. What is the mass number of Q? Q, where's Q? Right, okay, this one here. That one. So what you add is the number of protons and neutrons. And the answer will be 11. He says confidently. Before he can't add up. 11. Alright. Okay, which group of the periodic table is element T? Where's element T? Okay. It's got 6 electrons. So this is my first electron shell. I'm only allowed 2 electrons on there. Then I have to draw another shell. I'm allowed a maximum of 8, but I only need 6. So I need 1, 2, 3, 4. So now I've got 6. Okay, so how many electrons in the outer shell? 4. Yep. So it's got 4 electrons in the outer shell. So it will be in group 4. Which two represent isotopes of the same element. Right, for the electrons to be, for the atoms to be isotopes, they have to have the same number of protons. And the only two that have got protons that are the same are P and T. So we can put P and T. Which letter represents a positive ion? So what did you say an ion was? It is a charged particle. Let me give you an example. So here's hydrogen. H1, 1. So I've got one proton, that's come from there. And I've got a relative atomic mass of 1, so that means there's no neutrons. Because I've got one proton, I have got one electron. That is a hydrogen atom. Have you noticed that it is neutral? What does that mean? The same number of pluses equals the number of minuses. So protons equal electrons, the charges cancel out, it's neutral. Now if I were to get this rubber and rub this out, you can see that's gone. Now all I'm left with is a positive charge. So this hydrogen has a positive charge. Any charged particle is called an ion. So this here is a ion, and a positive ion is called a cation. I remember it as, is that plus, that T looks like a plus cation. Right, we need to go up, have a look. What is, right, we need to find out which one's got less electrons than it has. Right, we know them two are the same. We know them two are the same. We know, no, them two are the same. So it can't be them straight away, yeah? Let's get rid of that. So now we know it must be one of these two. So if you want more electrons, does it positive? Positive ion. So we need more pluses than minuses. We need more protons, where this number has to be bigger than this. So it can't be that. So it's that one and that one. And there you go. Which left? Oh, what R? Whoa. Not R, what am I talking about? S. Can't read. It's S. Okay. How does this diagram show? So that is a plus. That's neutral. And you've got two minuses. So we've got one plus, two minuses. Right. Them two cancel each other out. So you're left with an overall negative charge. So there. So there's one more electron than a proton. One more electron than a proton. There you go. Right, we'll this is half an hour, we'll pause it here. Okay. Yeah, do another one.